Record. Section functions. To graph a function quickly, a graphing calculator can be used to enter the function and then observe the graph on a rectangular coordinate system. Because sine and cosine both represent functions, the same can be done by graphing y equals sine of x and y equals cosine of x. Here, the independent variable x represents an angle measured in degrees or radians, and y, the dependent variable, represents the y-coordinate on the unit circle. Exploration 1, Introduction to Graphing the Sine Function. Complete the following table along with plotting the points and creating the graph of y equals sine x. In addition, as you're working, ask yourself why a table going from 0 to 2 pi was picked. Why is this enough to get an idea of what the graph of y equals sine of x looks like? So in the table, the first column, x represents an angle measure in radians from 0 to 2 pi, which is known as one cycle of the function. The second column are the y values, or function values for sine of x. The first row says for an angle of 0 radians, the sine function value is 0, and thus the ordered pair 0, 0. And the third column, which is the origin, represents 0 radians and a function value of 0. Pi over 6 radians, the sine function value is 1/2, gives the ordered pair pi over 6, 1/2, and so on. Now, the angle measures from 0 to 2 pi, and most of them are 6 or have a denominator of 6. And on the given graph here, the scale only shows halves, or pi over 2, pi, and 3/2 pi, and 2 pi. To find 6, we can think of converting pi over 2, or 1/2 pi, into 3/6. 1 pi is the same as 6/6 pi. Three pi over 2 converted to 6 will be 9/6 pi. And thus, starting with pi over 6, if we convert the interval from 0 to 3/6 into 3 equal parts, the first part will be 1/6 pi, then 2/6 pi, or 1/3 pi, and so on. Now on the vertical scale, it's marked from -1 to 0 to +1, and the midpoints are +1/2 and -1/2. So to graph pi over 6 1/2, that will be this point here where the laser pointer is. Pi over 2, 1 is going to be the first local max, top of the hill here, the peak value of 1. 5 pi over 6, 1/2 is plotted. And as we see, the function values begin to fall. The graph is falling until we hit pi radians, and the function value is 0. Now, beyond pi, the function values are still decreasing, heading toward -1. The angles are 7 pi over 6, -1/2, 3 pi over 2, the sine function value is -1, 11 pi over 6, the function value is -1/2, and finally, at the end of one cycle, At 2 pi radians, the sine function value is 0. So this is one cycle of the sine function from 0 to 2 pi. The x-axis can be called the center line or midline of the graph. Now, the angle x can be any real number, negative, 0, positive. And if we were to extend the graph in quadrant 3, negative pi over 6, the function value is negative 1/2, and the graph would continue right to left, containing negative pi over 6, comma, function value 1/2, negative 1/2, and then at negative pi over 2, the function value for sine is negative 1. Now, to the right, over at 2 pi and greater than 2 pi, the graph would continue rising and increasing and then repeating. Now, there are what are called 5 key points. The 5 key points are the origin, the local max at pi over 2 comma 1, the function 0 of pi, which gives a function value of 0, and 3 pi over 2, function value is negative 1, is the 4th key point, the local min. And the 5th key point is the endpoint at 2 pi, comma 0. As you see, there are 3 x-intercepts on the x-axis, and there are 2 local extrema, a local max and a local min. The interval from 0 to pi is divided into 4 subintervals. I'll highlight them in green here. So there's 0 to pi over 2, pi over 2 to pi, pi to 3 pi over 2, and then 3 pi over 2 to 2 pi. Those are the 4 subintervals. The length of those 4 subintervals is the total length of 2 pi divided by 4, which simplifies to pi over 2. So again, the length of each of the 4 subintervals is of length pi over 2. If we examine just one cycle from 0 to 2 pi, we call this angle from 0 to 2 pi the restricted domain, whereas the domain is all real numbers. The angle may be measured in radians, which is a real number, negative, 0, or positive. So in summary, the domain is that x, the angle, can be any real number. 2, the range or the function values vary between negative 1 and positive 1. Sine of x is greater than or equal to negative 1, and sine of x is less than or equal to positive 1. Another way to express this is the absolute value of the sine of angle x is less than or equal to 1. The sine function is an odd function, as the symmetry of the graph with respect to the origin indicates. For example, we could take this point on the graph at pi over 2 comma 1 at a local max, change the sign of the input from positive pi over 2 to negative pi over 2, and the function value is opposite in SIG and opposite in sine. The function value now is negative 1, whereas at pi over 2, the function value was positive 1. So we have opposite inputs x and negative x, and opposite function values, f of x and the negative of f of x. The sine function is periodic. Its function value repeats every 2 pi radians or every 360 degrees. The graph crosses the x-axis and its x-intercepts are occurring at 0 pi, 1 pi, 2 pi, and these are integer multiples of pi, or k times pi, where k is an integer from set Z, which includes 0. The y-intercept is the origin at 0 radians, comma, function value of 0. The maximum value is positive 1 and occurs when an angle terminates on the y-axis at negative 3 pi over 2, 1 pi over 2, 5 pi over 2, and infinitely more angles. The minimum function value is negative 1, occurring when the angle x is 3 pi over 2, negative pi over 2, which you get by subtracting 2 pi, or subtracting 4 pi over 2. So make a note here that we can obtain additional angles by subtracting 2 pi or adding 2 pi, or adding even integer multiples of pi. In example 1, we're going to graph functions of the form y equals coefficient capital A sine of omega x using transformations. Capital A is the coefficient of the function, and the basic function, the coefficient is 1. But as A increases in magnitude or absolute value, that'll affect the what is called amplitude, or the maximum positive peak of the function. Graph y equals negative 2 sine of pi x by describing in part A the basic function, which is y equals coefficient of positive 1 sine of 1x. Part B, what are the three transformations involved and how does it affect the basic function's graph? Now, A is negative 2 is the coefficient is less than 0, which means the parent graph, or the basic graph, is going to reflect over the x-axis. Now, since the absolute value of A, which is the absolute value of negative 2, is greater than 1, that means the basic graph will have vertical stretching. Omega is equal to the number that multiplies x, which in this problem is a 1. In general, the argument is omega times x. In this example, the argument is 1 times x, so omega is 1 pi. So since omega is pi, which is 3.14, and is greater than 1, that means the graph, the original graph, will have horizontal compression, and that occurs whenever omega is greater than 1. The length of one cycle is the period, which is identified, or the letter capital T is used, and the period is the fundamental period of 2 pi radians divided by omega. Now in the basic function, omega is positive 1. So if you were to divide 2 pi by 1 from the basic function, then the period would be 2 pi. Now, omega is in the denominator. It's a divisor. So if you increase omega, that means the period is going to decrease since you're dividing by a larger number than 1. And this will increase the frequency because if the period decreases, which is the length of one cycle, that means the graph is going to complete more cycles in the standard length of 0 to 2 pi, and thus has increased frequency. And that means it'll have more oscillations and complete more cycles from 0 to 2 pi. So the period generally is 2 pi, the fundamental period, divided by omega, which in this problem is equal to pi. So if we substitute pi for omega in the denominator, we get 2 pi divided by pi. Pi divides and cancels itself out, so we get 2 radians is the length of one cycle. So the horizontal scale, we're going to scratch it out and label 1 radian and 2 radians. For convenience, we're using 2 gray lines to represent 1 radian, and thus 1 gray line would be 1/2 of a radian. So the graph will complete one cycle between 0 and 2 radians. That's t, the period. Now, each subinterval has a length of t, the period, divided by 4. The period t is 2 radians, so that divided by 4 equals 1/2, or 0.5. So the 5 key points, the local max, local min, which are also called the local extrema, and the x-intercepts will occur at 1/2 radian. That's marked as 0.5. At 1 radian, 1.5, and 2 radians are the angles in radians where the 5 key points will occur. Now, let's pause for a moment and graph the basic sine function, which starts at 0 radians. And at pi over 2, I'm going to do this in light purple here, the peak value is 1. At pi radians, the sine is 0. So this dotted graph here represents the sine function, with the basic sine function, which will help graph with transformations. At 3 pi over 2, sine function value is -1. And at 2 pi, the sine function value is back to 0, and that would be the length of one cycle. So the 5 key points, let's highlight them in yellow here. There's 3 on the x-axis, a local max and a local min. Well, with a reflection, since A is negative, that means at 0.5 radians, there will be a local minimum at 0.5 radian -2. So this local max here will be reflected and then vertically stretched because A is 2 in absolute value. So let's mark that point and connect from the origin to that first point. Then at 1 radian, we'll have a third key point at 1.5 radians. As the graph continues to rise to the peak positive value of 2, the graph has a turning point, will fall and return to the x-axis at 2 radians. And that completes one cycle from 0 radians to 2 radians. Exploration 2. Graphing functions of the form y equals capital A as the coefficient cosine of omega x. So the argument is omega times the angle x, which may be in radians. Complete the following table along with plotting some points and creating the graph of y equals cosine x, one cycle of cosine x. So this table is also on the unit circle chart. And the first column represents an angle measure x in radians from 0 radians to pi over 3 radians, where the cosine is 1/2, pi over 2, the cosine is 0, and so on. 2 pi over 3, the cosine function value is negative 1/2. So we would plot points according to the ordered pairs in the third column. 0 radians, function value is 1. So the cosine function at 0 radians begins at its peak value of 1. Pi over 3, the function value is 1/2. So let's pause here and let's mark 1/2 and negative 1/2 on the y-axis. Now the angles that are given are at pi over 2, pi, 3 pi over 2, and 2 pi. But in the table, we have pi over 3, 2 pi over 3, 4 pi over 3, and other angles that are not on this scale on the graph. So let's think of pi over 2 as being 3 pi over 6. Pi is 6/6. And 3 pi over 2 in terms of 6 would be 9 pi over 6. So back to the table, pi over 3 is 2/6 pi. So to find 2/6 between 0 and 3/6, there would, if we marked 3 equal angles, they would be 1/6, 2/6, but 2/6 is pi over 3. Pi over 2 is 3/6. 2 pi over 3 is 4/6. And 4/6 would be one tick mark to the right of pi over 2. So here would be 4/6 or 2/3. And the function value is negative 1/2. So let's mark this angle for 6, which is 2 pi over 3. The next would be 5/6, then 6/6, then 7/6, and then 8/6. But 8/6 is 4/3. So 4 pi over 3 would be here. And in the table, the function value is negative 1/2. So that would be about here. 3 pi over 2, the function value is 0. And 3 pi over 2 is 9/6 pi. So the next tick mark would be 10/6, and 10/6 is 5/3, which is in our table. So this would be 5 pi over 3. and the function value is positive 1/2, which is approximately here. And then 2 pi, the function value was 1. So this is from 0 radians to 2 pi, 1 cycle. And the key points, we'll highlight in yellow here, are at 0 radians, function value of 1. Pi over 2 is a function 0, and it's on the x-axis, or the center line, also called the midline. Pi radians, function value for cosine is -1. And the fourth key point is at 3 pi over 2, which is a function 0. And at 2 pi radians, the function repeats at a function value of 1. The restricted domain RD is 0 to 2 pi. So to repeat, we'll use RD as an abbreviation for restricting the domain. Which generally is all real numbers, to 0 to 2 pi, and call that the restricted domain for the angle x, which may be in radians. Now, if we take the period, which is 2 pi radians, again, that's the fundamental period. So period, fundamental period is t is 2 pi. Now that length of 2 pi, if we divide it into 4 subintervals, it'll be from 0 to 2 pi, 0 to pi over 2, pi over 2 to pi, pi to 3 pi over 2, 3 pi over 2 to 2 pi. The length of each of those is going to be pi over 2, because if you take the fundamental period, 2 pi, and then you divide that by 4, 2/4 is 1/2, or pi over 2. So pi over 2 is the length of one of the 4 subintervals. So number 1, properties. The domain is that x, the angle, can be any real number in radians. 2, the range consists of values for cosine of x between -1 as a lower bound and +1 as an upper bound. This is equivalent to the absolute value of the cosine of x is less than or equal to 1. The cosine function is an even function and displays symmetry of the graph with respect to the y-axis. So that means if you were to look at the point pi over 2 comma 0 and think of the opposite input, which is negative pi over 2, the function value is the same at 0. And again, you see this y-axis symmetry. 4, the cosine function is periodic. Its value repeats every 2 pi radians, or every 360 degrees. The x-intercepts are where the graph crosses the x-axis, which occurs at pi over 2. And if you subtract pi, you get negative pi over 2. If you subtract pi again, that's -2/2 pi, which is -3/2 pi. Now from pi over 2, if you were to add pi, which is 2/2 pi, you would get +3/2 pi. The y-intercept occurs at 0 radians. The function value is 1. Number 6, the maximum value of the cosine function is 1 and occurs at 0 radians. 2 pi radians, clockwise negative 2 pi radians. So these are even integer multiples of pi. The minimum value for cosine is -1 and occurs at pi radians. And if you were to subtract 2 pi from pi, you'll be at -1 pi. Or from pi, if you add 2 pi, which is its fundamental period, you get 3 pi. So plus minus pi, plus minus 3 pi, these are odd integer multiples of pi. Example 2, graphing functions of the form y equals coefficient a cosine of argument omega x, where omega is a positive number that multiplies angle x in radians. For example, graph y equals 1 cosine of 2x minus 3. By first describing in part A, what's the basic function we are graphing? The basic function is y equals coefficient of +1 cosine of +1x. So if we were to emphasize the argument, it's +1x. What are the two transformations involved and how did it affect the basic function graph? First, the argument in the problem that we're doing, the argument, its omega is +2. And whenever omega is greater than 1, this means the basic graph will undergo horizontal compression, which means that the period t is going to decrease. 2 minus 3 means that there's going to be a vertical shift downward, including the center line or midline. In general, the period t equals the fundamental period for cosine, which is 2 pi divided by omega. In this example, the argument has omega of 2, so 2 pi divided by 2. The 2's will divide and cancel, so the period is 1 pi. That means that one cycle will start and end and have a length of pi radians, and if we start at 0 radians, it will end at pi radians. All right, let's start with the center line or midline. So the center line is normally the x-axis, but now after a vertical shift down 3 units, graph in the new center line, whose equation is y equals -3. And let's show the basic function, the cosine function. It begins at its peak value of 1. So at 0 radians, we have a function value of 1. At pi over 2, the cosine function value is 0. At pi radians, the cosine function value is -1. So if we fill in here with a light purple graph, the graph is decreasing. Let's make it more curved here. So it's decreasing with some curvature. And then containing pi comma -1. Now this graph has a vertical shift down of 3 units, but the coefficient of 1 means there's no vertical stretching. So it's going to start at 0 radians, comma, function value of -2. Let's do this in green here. So that's going to be its starting point. 0 radians, function value -2. So we want to show 5 key points where the graph is falling. And let's also show the 4 subintervals. 4 subintervals have length of the period t, which is pi, divided by 4. So that means that the 5 key points will occur at angles of pi over 4, 2 pi over 4, 3 pi over 4, and 4/4 pi. So if we start at 0 radians, function value -2, the next key point is going to occur at pi over 4 and a function value of -3. The next key point will occur at pi over 2, and the function value would be at -4. The fourth key point will be at 3 pi over 4, and the function value will be -3. And then the fifth key point will be at pi radians, and the function value will again be repeating at -2. So let's connect these points with a curve that looks like a cosine curve. At 0 radians, it starts at its peak value of -2, then begins to decrease, reaches -4 as a function values. Then function values begin to increase, the graph begins to rise and gets back to -2 at pi radians, and then repeats. Exploration 3, sinusoidal functions. As defined in many dictionaries, sinusoidal functions are of relating to, shaped like, or varying according to a sine curve. This means that any curve that is a transformation of the sine curve is called a sinusoidal function. Part 1. Graph the cosine function in the grid below and the space below. Then shift the graph of this curve to the right pi over 2 radians. What do you find? So the cosine curve starts at 0 radians and its peak value of 1. At pi over 2, cosine is 0. At pi radians, the cosine is 1. At 3 pi over 2, cosine is -1. And at 2 pi radians, the cosine value repeats. It's back at +1. Now, if we take those 5 key points and shift them to the right by pi over 2, then the first point, which was at 0, 1, will be at pi over 2, 1. Right, as that point is shifted to the right. The second key point at pi over 2, 0 shifted to the right will give pi, 0. The next key point at pi radians -1 shifted to the right will give at 3 pi over 2 -1. The fourth key point at 3 pi over 2, 0 shifted to the right will be at 2 pi. And then the fifth key point at 2 pi radians, 1 shifted to the right will be at 5 pi over 2, 1. Now, if we were to connect these 5 blue points right to left, and keep in mind it's a sinusoidal shape, the graph's going to look like this, again going right to left. Now let's keep going and repeat this pattern. You see, we're going to get back to 0. And that's where the sine function begins. The sine function at 0 radians has a function value of 0. So the meaning of this is the cosine function, cosine of x, shifted to the right horizontally by pi over 2 means that the value of the function, cosine of x minus pi over 2, is the same as the sine of x. Because the graph of the sine of x is obtained by shifting the cosine of x to the right pi over 2 units. Now, this relates to earlier study of horizontal shifting, where if you have a basic function f of x and you transform the argument to x subtract a positive number, pi over 2 being the positive number, and pi over 2 is small h, then the basic graph will horizontally shift to the right if small h is a positive value. And that's what's occurring here. The cosine function, its basic graph is shifted to the right by pi over 2 units if the argument is changed to x minus pi over 2, and then you obtain the graph of the sine of x. And therefore we have this relation, the cosine of x minus pi over 2 is equal to the sine of x. Exploration 4. Determine the amplitude and period of sinusoidal functions. Because the sine and cosine functions are transformations of each other, the sine and cosine functions are called sinusoidal functions. Let's explore some generalities about these sinusoidal functions. Complete the table below by looking at the graph of the following functions at Desmos. Cosine of x, function g is 2 times cosine of x. So you see the coefficient is now 2 versus positive 1 on the basic function. And 1/2 cosine of x is function h of x. So we're going to go to Desmos and look at the range values for cosine of x. Function g is 2 times cosine of x, and function h is 1/2 times cosine of x. So here is the basic function y equals positive 1 cosine of x. One cycle has length 0 radians to 2 pi. 2 pi is 2 times 3.14 is about 6.28. And so here you see 6, and a little past 6 will be 2 times pi radians, 2 pi radians. Now the function g is 2 times cosine x. And you can see the maximum positive peak value is positive 2. And on the low side, the absolute least negative value is negative 2. So the range from low to high, minimum to maximum, is negative 2 to positive 2. And the third function is 1/2 cosine x, or 0.5, 0.5 cosine of x. That's the green graph, and you see it's maximum positive value is 0.5 or 1/2, and its absolute least negative value is -1/2. So the range is from the minimum to the maximum is -1/2 to +1/2. So filling in the table here, we have the range on the basic cosine function is -1 to +1. Function g's range is -2 to +2, which is related to the coefficient capital A. And function h's range is -5 to -0.5 to +0.5. In general, the values of the functions y equals capital A sine of x and y equals capital A cosine of x, where a is not 0, also satisfy the inequalities where the value of a times sine of x is bound between the lower bound is the opposite of the absolute value of a. Since a could be negative, the absolute value of a makes the quantity positive, so here you're guaranteed the lower bound is a negative value. And at most, the function value will be the absolute value of a. Again, it's absolute value because the coefficient a could be negative, but the absolute value of a gives you the maximum positive value that the function can have. Same for a cosine of x. It is bound, its lower bound is the opposite of the absolute value of a. So put in this bar that seems to be missing here. And the upper bound, which means the greatest that the function value can be, is the absolute value of a. The value of absolute value of a is given the name amplitude because it dictates the maximum height or peak of the graph. In terms of transformation, it determines the vertical stretch or compression. Why do you think the amplitude is the absolute value of a? If a is a negative value, and if cosine theta is its maximum of 1, then the maximum peak function value is the absolute value of a times 1, which is the absolute value of a. Again, 1 is the greatest value of the cosine of theta. 2. Complete the table below by looking at the graphs at decimals of the following functions. So function f is the basic cosine function, coefficient of 1, and omega in the argument is 1, since that's 1 times x. Function g is cosine of 3 times x, so omega is +3. And function h is the cosine of 1/4 times x, or x divided by 4. So let's look at these three functions. Well, again, cosine x we already have. Let's go to cosine of 3x. +3 times x. Now you see the purple graph, it's got more oscillations between 0 and 2 pi. It has a higher frequency, which means it completes more cycles as compared to the basic function between 0 and 2 pi. And its period has shortened. In other words, it completes one cycle in 2/3 pi radians versus 2 pi radians. And the red graph has been horizontally compressed, making the period shorter, and the frequency has increased. Notice that on 2/3 pi, 3 is the value of omega in the argument, 3 times x. And looking at function h is 1/4 x, positive 1 cosine x divided by 4. That's the black graph, and you can see it's kind of horizontally stretched out. It starts its peak value of 1 at 0 radians, and if you follow it, crosses at a little beyond 6 radians or 2 pi radians. Follow the black graph. There's a local min there at 4 pi radians, and then finally it's back at 1, function value of 1, at 8 pi radians. Now there's a relationship between the 8 and the 4 on x divided by 4. Let's see what the relationship is. Before we do that, keep in mind the black graph compared to the basic function graph is horizontally stretched. Its frequency is decreased. It takes 8 pi radians to complete one cycle. Let's go back to summarize here. So in the table here, the first entry, the period is the fundamental period, which is 2 pi. Using this formula, period is fundamental period of 2 pi divided by omega, and omega is 3 in the middle chart here, middle of the chart. So that's 2 pi over 3, which is what we saw on Desmos. And for the function h, we saw the period or the length of one cycle from 0 radians until the angle where it began to repeat was 8 pi radians. Now, if you take 2 pi, the fundamental period, and you divide by omega, which is positive 1/4, you get 8 pi. So we see that's how, in general, the values of the functions y equals sine omega x and y equals cosine of omega x, where a is positive, and omega by definition is positive, greater than 0. The period is 2 pi divided by omega and represents the length of one cycle of the graph. Based on your knowledge of transformations, why does this change to the period, decrease or increase, make sense? Recall, given a basic function, f of a times x, where a is multiplying the input in the argument, there will be horizontal compression if a is greater than 1. For cosine omega x, there will be horizontal compression if omega is greater than 1. And the period will decrease, and there will be a higher number of frequencies or oscillations, and the frequency increases. That means more oscillations in the standard of 0 to 2 pi. So if omega is defined to be positive, omega is greater than 0, the amplitude and period of y equals a sine omega x and y equals a cosine omega x are: amplitude is the absolute value of the coefficient a. Period is defined by the letter capital T, which for sine and cosine is the fundamental period of 2 pi divided by omega. Now, since omega is always a positive value, when you divide 2 pi, which is positive, by omega, which is positive, that means the period is going to always be a positive value, greater than 0. Example 3, determine the amplitude and period. In part A, y equals -4 cosine of 3x. The amplitude is the absolute value of the coefficient A, which is going to be the absolute value of -4. So the amplitude is 4. The period, t, is the fundamental period, which is 2 pi, divided by omega. Omega in the argument multiplies x, which is 3. So the period is 2/3 pi, or 2 pi divided by 3, which is written below. Part B, y equals 1/2 times sine of negative pi x. Well, first, to make omega positive, we're going to use the odd property of the sine function, which means the sine of negative theta is the opposite of sine theta. And again, that's because if negative theta is opening clockwise, the sine value will be opposite the sine of theta, because theta is opening counterclockwise into quadrant 1. Then the given equation becomes y equals negative, due to the negative that kind of goes in front, or -1 that multiplies sine of the argument. So -1/2 sine of omega x. So now omega is the value pi, positive pi. The amplitude is the absolute value of A, is the absolute value of -1/2, is +1/2. The period is the fundamental period of 2 pi divided by omega. Omega is the value positive pi, then pi divided by pi will divide and cancel out. So the period, or the length of one cycle, is 2 radians. So to repeat the idea of 5 key points, the basic sine function starts at the origin, 0, 0. As the angle increases to pi/2, the sine value increases to 1. Beyond pi/2, increasing toward pi radians, the sine function value is decreasing, reaches 0 at pi radians. That's the third key point. The next key point, as y becomes more negative and reaches -1 at 3 pi/2, is the fourth key point. Now beyond 3 pi/2, we're into quadrant 4 now. Y is negative, but it's increasing to 0. And then the function value repeats at 0 at 2 pi. Now the basic cosine function at 0 radians begins at its peak value of 1. And as the angle x opens counterclockwise in a quadrant 1, x in length is decreasing to 0 at pi/2. Beyond pi/2, we're heading toward pi. The cosine of the angle is negative. It reaches -1 at pi radians. Beyond pi radians, heading toward 3 pi/2. 3 pi/2 is a function 0. And then the cosine value is now positive in quadrant 4 and increases to its maximum of 1 at 2 pi radians. Both graphs can be broke into or divided into 4 subintervals. And if we take the fundamental period of 2 pi and divide by 4, because there's 4 subintervals, we get pi/2 is the length of each of the 4 subintervals. So we have 0 to pi over 2, pi over 2 to pi, pi to 3 pi over 2, and 3 pi over 2 to 2 pi. Same thing with cosine function. We have the same 4 subintervals, each of length pi over 2. So just to repeat, since the fundamental period is 2 pi, when we divide 2 pi by 4, that's how we get 2/4 pi, or pi over 4, sorry, pi over 2, half of pi, is the length of one subinterval. Now, the general steps for graphing a sinusoidal function, y equals a sine omega x, or y equals a cosine omega x. First key point is to determine the amplitude, which is the absolute value of a, and the period, which is the fundamental period, 2 pi divided by omega, which multiplies x in the argument. Step 2, find the length of each of the 4 subintervals, which is the period t, which you find in the step above, and then divide that by 4. Step 3, use subinterval endpoints to find 5 key points. Step 4, draw one cycle of the sinusoidal curve. Example 4. Graph y equals 4 times sine of 2x. The amplitude is the absolute value of a is the absolute value of 4 is equal to 4. The period t is 2 pi divided by omega, which is 2 pi divided by 2, because 2 is in the argument that multiplies x. And the 2 divided by 2 will divide and cancel out. So you get pi radians. So the length of one cycle is pi radians. Now we take the period, which is pi, and divide that by 4 to get the length of each of the 4 subintervals. So period t divided by 4 is pi divided by 4. So the 4 subintervals, starting with 0 radians, we're going to add pi over 4 because that's the length of one subinterval is pi over 4. Now the next subinterval starts where we left off at pi over 4, and since the length is pi over 4, we add pi over 4, and pi over 4 plus pi over 4 is 2/4 pi, which is 1/2 pi, or pi over 2. So we're adding pi over 4 to pi over 4. And then repeat. Starting at pi over 2, that's the first angle at the start of this interval, we add, let me add a note here. So each interval starts at an angle, we're adding pi over 4, or 1/4 pi. From pi over 2, which is, in terms of quarters, 2/4, add 1/4 is 3/4. Then from 3/4, that's the first angle on the next and fourth interval, we add pi over 4. 3/4 plus 1/4 is 4/4, which is 1 pi. So the very first angle is 0 radians, and the period is pi. So the last angle has to be pi, because the length from beginning to end is pi radians. That's the period. All right, so let's start graphing. The first key point will be for the sine function. Normally it starts at 0, comma 0. Matter of fact, let's pause here and put in the basic sine function. Key points are at 0, 0, the origin. At pi over 2, the sine function value is 1. And at pi radians, the sine function value is back to 0. So I'm going to sketch this in sort of lightly here. From 0 to pi, that would be the sine function, but only from 0 to pi. Now, 4 times sine of 2x is going to complete one cycle from 0 to pi. The 5 key points will occur at angles of 0 radians, and the next key point will occur at an angle of pi over 4 radians. And we're just going to keep adding pi over 4 as we did earlier. So the next one would be 2/4 pi, or pi over 2. This is going to be the angle where the third key point occurs. And then the fourth key point will be at 3 pi over 4. And the fifth key point will occur at pi, the end of one cycle. So the first point will be the origin, 0, 0, so we have a common point. Now at pi over 4, due to the vertical stretching, the coefficient A is 4 and the amplitude is 4, we're going to have a point and a local max at pi over 4, comma 4. So let's fill in those ordered pairs, 0, comma 0, pi over 4, comma 4. Then at pi over 2, since the graph is going to increase from the origin, rise, and then fall. To 0 at pi over 2. So at pi over 2, the function value is back to 0. The next angle where a key point will occur is at 3 pi over 4. Let's mark this one. And since the graph is falling below the x-axis, we will reach a local minimum. The bottom point here at 3 pi over 4, function value is -4. We have a local min, the graph begins to rise, function values increase until we get to a common point there at pi radians, comma 0. So filling in the last two with the 5 key points, 3/4 pi, the function value is -4, and at pi radians, the function value is back to 0. Example 5. Keep in mind that by definition, omega is a positive value. Also, the cosine functions have an even property, so the cosine of negative theta, which would be clockwise, is the same or is equal to the cosine of theta, which is counterclockwise. Graph y equals -5 times the cosine of -pi over 2x. The argument has a negative sign on omega. So that's the opposite of omega because omega has to be positive. So by the even property of cosine functions, we can kind of drop, so to speak, drop the negative sign on the argument, because the cosine of negative pi over 2x is equal to the cosine of pi over 2x. Of course, we still have the negative sign on the outside, on the negative 5. So the negative 5, which is capital A, since A is negative, this will cause reflection over the x-axis, since, symbol for since, A is negative. The amplitude is the absolute value of A, is the absolute value of 5, equals positive 5. The period, t, is 2 pi divided by omega. Omega is equal to positive pi over 2, and this simplifies to 4 radians. So the length of one cycle will be 4 radians. The period, 4 radians, divided by 4 is 4 divided by 4, which is 1 radian, and that's the length of one subinterval. Let's add a note here that the length of one subinterval is 1 radian. Length of one subinterval. Again, it's t divided by 4. The period t is 4 radians divided by 4, and that's why it's 1 radian. So on our graph here, we'll mark 0 radians, 1 radian, 2, 3, and 4. The 4 intervals will go from 0 to 1 radian, 1 to 2 radians, 2 to 3, and 3 to 4 radians. Now, let's plot the basic cosine function. Let's do that in red. The basic cosine function at 0 radians begins at its peak value. In this case, it would be 1. Now, if we were to mark and show, let's say, pi over 2, let's say that this is pi over 2 in red. Every 2 lines is pi over 2, so this would be pi, 3 pi over 2, and 2 pi. So the cosine at pi over 2 is 0. At pi, cosine is -1. At 3 pi over 2, cosine is 0. And at 2 pi, cosine is 1. All right, so let's sketch in the cosine function from 0 to 2 pi. It's going to look something like this. Right, that's our basic function. Now the function we're graphing has a negative coefficient and amplitude of 5. So it's going to start at 0 radians, -5. Let's go to blue here. And it's going to start increasing and reach a function 0 of 1 radian. So here are the first 2 key points. Increasing to 1 radian. The next key point will occur at the next key angle, which is 2 radians, where we're going to have a maximum positive peak value of 5. The graph will increase, rise, and rise, and then there will be a turning point and a local max at 3. As the graph continues to continue symmetrically, 3 radians is a function 0. And then at 4 radians, we're back to a function value of -5. And there's a sketch of the function. From 0 to 4 radians, the length of one cycle. On both example 4 and 5, if plus 2 were added on the end of the function, how would this alter the graph? Y equals a cosine of omega x plus beta in general. The effect would be a vertical shift down if b is a negative value, and a vertical shift upward if b has a positive value. Example 6. Find an equation for the given sinusoidal graph. So let's look at this curve here. If we, as a reference or starting point, start at 0 radians, we notice there's not a positive peak to start with like cosine does. There's a negative peak. So there's a reflection going on of some kind of a cosine function. And if we follow the curve to where it starts to repeat, we can determine the function value of -3 begins to repeat after 8 radians by reading the scale above. So again, if you follow from a starting point, let's say we start at 0 radians, comma -3, the graph begins to repeat at 8 radians. So that means the period is 8 radians, which is t. So because we observe a reflection of a cosine function graph, we think this graph is that of some cosine equation. The amplitude is determined by the maximum positive peak value, which is 3. So the amplitude is the absolute value of A, which gives +3. And because of the reflection, A must be -3. But the amplitude is 3, which is the absolute value of A. The period is t. The length of one cycle is 8 radians. And by the formula, period t is the fundamental period of 2 pi divided by omega. We'll substitute 8 for t. 2 pi is just the constant, and omega is the variable we don't know that we're solving for. So we'll take this proportion and diagonally cross multiply. We get 8 times w is equal to 2 pi. To solve for omega, we'll divide by 8 on both sides. 2 divides 8 4 times. We get pi over 4. Now pi is roughly 3. 3/4 is less than 1. And whenever omega is less than 1, that means we're going to get horizontal stretch. So the fundamental period of cosine or sine is 2 pi radians, which means one cycle will complete in 6.28 radians. But because omega is less than 1, the period has increased from the fundamental period of 2 pi, which is 6.28 radians, to 8. The period has increased. So in general, the equation or cosine function is a times cosine omega x plus beta. A, we determine the amplitude is negative due to the reflection of a cosine graph. The amplitude was +3. Cosine of omega was determined to be pi over 4. So we substitute pi over 4 for omega. And there is no vertical shift up or down from the center line or midline. The graph fluctuates with respect to the x-axis with no vertical shifting, so beta is 0, and we don't have to show plus 0. Can leave that out.